Carbohydrates are prolific in our day-to-day lives. Whether it's the food we eat, things we drink, supplements we take, our dietary restrictions, or health conditions, carbs affect everybody. We know these are important compounds to monitor within ourselves and what we consume, but detection of these compounds is multifaceted. In some cases, assays or refractometry are appropriate means of detection, but in many cases, chromatography is required. Because carbohydrates exhibit no useful optical absorption, electrochemical detection is the preferred method for chromatographic detection. This is typically done with a gold electrode, but these electrodes often have short lifespans and are used disposably. To extend the lifespan of, and to reduce the material cost for these electrodes, we have fabricated a continuously renewed copper electrode. This electrode is comprised of a copper wire sheathed in tubing that is sealed by a compression fitting. The electrode extends into a T-junction here and is separated from a stainless steel tube opposite the electrode by a thin piece of annular plastic. Sometimes you may hear this referred to as a donut. In the T-junction, flow distributors, based off of designs used in quartz crystal microbalances, have been cut so that eluent is evenly dispersed around the electrode while not blocking the T outlet. This electrode has so far been used as a detector for ion chromatography, which uses basic eluents such as potassium hydroxide. The hydroxide oxidizes and subsequently dissolves the copper electrode, so a plunger, seen here, has been fashioned from a tungsten carbide drill bit to continually reposition the electrode. We can see the actual manifold over here. The plunger is driven by a continuous feed of compressed air, which pushes against the drill bit's nylon collar. Because the drill bit is in constant contact with the electrode and the tubing opposite the electrode is made of a conductive material, an electrochemical cell is formed when a potential is applied between them. We see this in the alligator clips here and here at opposite ends of the device. Thus far, the copper electrode has demonstrated subparts per million sensitivity with simple sugars, seen here, has been able to resolve complex mixtures of long-chain carbohydrates, as seen here with an inulin sample which has more than 100 peaks associated to it. Long-term stability experiments have been conducted, but a gasket failure cut the experiment short after just 2 weeks. A new long-term stability experiment is currently underway, and a patent application for the design has been filed with the U.S. Patent Office.